Hello friends, I am Chetan Devidas Ingale, working as an assistant professor in Department of Chemistry, RBNB College, Shirampur. Up till now, in our last few lectures, we have studied about what is meant by alcohol and its types. In this lecture, we will go to learn properties of alcohol. One by one, we see the properties of alcohol. We know that the first property of alcohol is nothing but as the number of carbon atom increases, its melting and boiling point increases. As the number of carbon atom increases, melting and boiling point increases. We also know that when the number of carbon atom increases, obviously its molecular weight increases, that is molecular weight of alcohol increases. As the molecular weight increases, obviously its boiling or melting point also increases. For example, the boiling point of methyl alcohol is equals to 64.5 degrees Celsius. Whereas when we determine the boiling point of N-pentyl alcohol, we know that it arises as 138 degrees Celsius. In this case, that is in case of methyl alcohol, only one carbon atom is present, whereas this pentyl alcohol has 5 carbon atoms. Hence, as the number of carbon atom increases, its melting and boiling point increases. Now the second property is nothing but, as branching increases, melting and boiling point decreases. As branching increases, melting and boiling point decreases. This is so because as the branching increases, the surface area of that branch molecule decreases. It means the volume of that molecule collects in a small region, and to melt down or to boil such branch compound due to decrease in its volume or surface area, we require small amount of energy. It means to boil or to melt such molecule, that is branch molecule, small amount of energy will be needed. That's why its melting and boiling point decreases. Now for example, the melting point of N-butyl alcohol is 118 degrees Celsius, 118 degrees Celsius. Whereas when we determine the melting point of tertiary butyl alcohol, it arises as 36 degrees Celsius. This is all about as branching increases, melting and boiling point decreases. We know that this is the straight chain compound, whereas this is branch compound. So in this way we explain why branching increases and boiling or melting point decreases. Now next, now the third property of alcohol is nothing but when we compare the alcohol, when we compare the melting and boiling point of alcohol with alkanes having comparable molecular weight, then we know that due to increase in hydrogen bonding, due to presence of hydrogen bonding in case of alcohol, the alcohol has higher melting and boiling point. Than that of comparable or considerable alkanes. Okay, the third property is nothing but alcohols have higher melting and boiling point. With respect to what? With respect to alkanes. It means when we compare the melting and boiling point of alcohol with such alkane which has nearly same, with alkanes with nearly same molecular weight, okay. Now we know that the molecular weight of N-pentane is this N-pentane is nothing but 76. Okay, and it is 70. And when we see the molecular weight of tertiary butyl alcohol, that is it arises as 74. When we compare the molecular weight of these two, we know that it has 74, whereas it has 70 molecular weight. Now, when we compare the boiling point of these two, definitely on the basis of hydrogen bonding present in alcohol, we say that the boiling point of this alcohol is high as compared to this alkane, besides having near about same molecular weight. Okay, now the next property, that is solubility. The lower alcohols are easily soluble in water, but as the number of carbon atom increases, the hydrocarbon moiety increases. Due to increase in hydrocarbon moiety, it means non-polar character in that alcohol also increases. That's why lower alcohols are soluble in water, are water soluble. But when we see the higher alcohols, that higher alcohols are obviously due to higher non-polar character of alkyl chain or due to higher hydrocarbon chain becomes water insoluble. These are the some properties of alcohols. Now we have to move towards our next topic, that is preparations of alcohol. पहिला preparations. The first preparation is nothing but using Grignard reagent. That is nothing but RMGX. The alkyl group present in Grignard reagent, that is RMGX, has negative charge. Due to negative charge, it becomes nucleophilic in nature. It means it becomes electron rich. And we know that electron rich, that is nucleophile, always attack on the electrophilic center. When we have to use this Grignard reagent, it will be prepared in situ. It will be prepared in situ. Now, the first preparation of alcohol is related with the preparation of primary alcohol. Now, preparation of primary alcohol. We know that what is meant by primary alcohol now. If OH group is directly attached to primary carbon atom, then that alcohol is called as primary alcohol. Now, when formaldehyde molecule, that is CH2CO, CH2O, when this formaldehyde is treated with methyl magnesium bromide, this methyl group will attack on this carbon atom and we obtain this complex as an intermediate. Now this intermediate undergoes hydrolysis to form alcohol as a product. To form primary alcohol as a product. That is ethyl alcohol here. That is ethyl alcohol here. Now, this is the first reaction, that is preparation of primary alcohol. Now, by using same Grignard reagent, we will be able to prepare secondary alcohol as well as tertiary alcohol also. Now, preparation of secondary alcohol, that is preparation of secondary alcohol. Now, to prepare secondary alcohol, we have to use aldehyde, that is R C double bond OH. I consider this alkyl group as R1 when this aldehyde molecule is treated with Grignard reagent, that is R2MgX. We know that as being the nucleophile, this negatively charged R2, that is alkyl group 2, will attack on this carbonyl carbon to form or to prepare such a compound, which on hydrolysis gives secondary alcohol. Which on hydrolysis gives secondary alcohol, that is R1COH R2. This is the general reaction of preparation of secondary alcohol by using Grignard reagent. Now consider an example of acetaldehyde. When this acetaldehyde molecule is treated with methyl magnesium bromide, we obtain directly, I write the product, we obtain 2-propanol as a product, which is nothing but secondary alcohol, because the OH group is directly attached to secondary carbon atom. Now, like the preparation of secondary alcohol, we have to know that to prepare tertiary alcohol, instead of this acetaldehyde molecule or instead of any aldehyde, we have to use ketone molecules. That is preparation of tertiary alcohol. Now, instead of this aldehyde, if we use ketone, or for example, I will take direct an example of this. When this acetone molecule is treated with methyl magnesium iodide, we know that obviously these nucleophilic species will attack on this carbon atom to form this complex, which on hydrolysis gives tertiary butyl alcohol as a product. And we know that this carbon atom, as it contains 3 different carbon atoms, becomes tertiary carbon atom, and if OH group is directly attached to tertiary carbon atom, it becomes tertiary alcohol. This is all about the preparation of alcohol by using Grignard reagent. Now, the attack of Grignard reagent on epoxide, that is ethylene oxide, and esters, we will see in our next lecture. Thank you.